Since its introduction into service in 2005, the F-22 Raptor has become a cornerstone of American air power strategy. Its versatility and ability to effectively achieve air superiority have made the fighter an indispensable asset for the U.S. Air Force. However, with more countries gaining access to new stealth fighters and advanced drones, the question arises, can the Raptor continue to maintain its dominance? We'll be trying to answer that question in today's video. Despite the fact that the term Advanced Tactical Fighter, ATF, started appearing more and more often from representatives of the U.S. Air Force since the early 1970s as a description of future tactical aircraft, the actual program under the same name started only in 1981. As part of it, the U.S. Air Force began developing an air superiority fighter whose characteristics were supposed to be superior in every way to the previous generation, the McDonnell Douglas F-15 Eagle. The main threat of the ATF era was considered to be the Soviet Sukhoi Su-27 flanker, Mikoyan MiG-29 Fulcrum fighters, Beriev A-50 mainstay airborne early warning and control aircraft, AWACS, as well as increasingly complex surface-to-air missile systems. The latter worried the military quite a bit after the Vietnam War and the Arab-Israeli War of 1973, which demonstrated the lethality and complexity of the USSR anti-aircraft missile systems. Work on developing the requirements for the future air superiority fighter began in 1981 under the codename Senior Sky. And although at the start the military was unable to accurately determine whether the aircraft should be focused on air-to-air or air-to-surface classes, it did manage to identify four clear concepts. Numbers Fighter, N, with a lightweight, inexpensive design that combines lower individual capability for quantity. Supersonic Cruise and Maneuver, SCM, is a vehicle with a takeoff weight of approximately 55,000 pounds, high maneuverability, and specific excess power at transonic and supersonic speeds. Subsonic Low Observable, SLO, a version that sacrifices the characteristics and speed of the fighter for the sake of its stealth to the enemy. High Mach High Altitude, HI, a big and fast missileer aircraft with a takeoff weight greater than 100,000 pounds, designed to fly at speeds greater than Mach 2 and at altitudes of 50,000 feet. After weighing all the pros and cons, the U.S. Air Force decided that the most sensible thing would be not to choose one, but to combine several of the most successful concepts at once, SLO and SCM. As for the N and HI options, these did not receive high marks, and the companies invited by the service to participate in the development of the future fighter were also advised to avoid extremes in the spectrum of quality and quantity. The final set of requirements for 1984 looked like this. Takeoff weight 50,000 pounds, range of at least 800 miles, super cruise speed Mach 1.4 to 1.5, option of using a 2,000-foot runway, reduced visibility, especially in the frontal sector. In the summer of 1986, the service received offers from Boeing, General Dynamics, Lockheed, Northrop, McDonnell Douglas, Grumman, and North American Rockwell. Granted, the latter two soon announced their withdrawal from the race. The choice was settled on two candidates, Lockheed and Northrop, each of which had to present its own prototype, later better known as the YF-22 and YF-23. In parallel with this, as part of the ATF engine program, new engines were being prepared for each of the prototypes, YF-119 from Pratt & Whitney and YF-120 from General Electric. As a result, the YF-23 went into greater stealth and speed, while the YF-22 acquired impressive maneuverability and nozzles with variable thrust vectoring. Deciding not to expose the program to unnecessary expenses, the U.S. Air Force chose the option from Lockheed, considering Northrop's brainchild too risky of a gamble, although later on Raptor borrowed many features from its opponent. The Raptor remains to this day one of the most advanced air platforms on the planet, and stands up well in comparison with the best fighters of the United States' overseas buddies, Russia and China. The F-22 was not only the pioneer of fifth-generation fighter aircraft worldwide, but also the first operational aircraft to combine supersonic cruise, super maneuverability, stealth, and the latest integrated avionics in a single weapons platform. This allowed it to survive and carry out offensive or defensive air operations even in the harshest of conditions. But before moving on to this reptile's weapons array, let's talk about its design. The shape of the fighter managed to harmoniously combine stealth and aerodynamic characteristics. Plane form and the edges of the panels are aligned, and the surfaces have a continuous curvature to minimize the radar cross-section. Cropped diamond-like delta wings flowing into angular fuselage with 4 tail surfaces and leading-edge root extensions extending to the upper outer corner of the carriage inlets. The upper edges of flight inlets include leading-edge flaps, flaperons, ailerons, rudders on inclined vertical stabilizers, and all moving horizontal tails. In order to brake, the ailerons are deflected upward, the flaperons are deflected downward, and the rudders are deflected outward, all to increase resistance. And since supersonic characteristics are extremely important for the F-22, the area rule, aka Whitcomb area rule, is widely applied to the fighter uniform. Almost the entire fuselage volume is located under the trailing edge of the wing. At the same time, the stabilizers rotate from the tail booms extending beyond the engine nozzles. The engines are 2 Pratt & Whitney F-119 turbofans. Each produces 35,000 pound-feet, and their specially designed nozzles can move in a vertical plane, directing all 70,000 pound-feet of the aircraft's thrust in a single direction. Moreover, this will work brilliantly even if the F-22 itself is moving in a different direction, allowing pilots to perform crazy acrobatics or use an extremely high angle of attack during a dogfight within visual range. In terms of avionics, the Raptor was also ahead of its time, having received the most advanced and powerful radar, the Westinghouse Texas Instruments AN/APG-77. It has a stealth active aperture electronically scanned antenna with multiple tracking targets during scanning in all weather conditions, and its radiation can be focused to overload enemy sensors during an electronic attack. Additionally, the radar changes frequencies more than 1,000 times per second to reduce the likelihood of acquisition and has an estimated range of 125 to 150 miles against an 11 square foot target and 250 miles or more in narrow beams. Complementing the radar is the ALR-94 electronic warfare system, one of the most technically sophisticated devices installed in the F-22. It integrates over 30 antennas built into the wings and fuselage for all-round radar warning receiver, RWR, and geolocation of threats. Furthermore, it can be used as a passive detector, capable of searching for targets at ranges exceeding the range of radar and providing enough information about enemies for radar acquisition and cue emissions to a narrow beam. In fact, the Raptor's ability to operate close to the battlefield gives it threat detection and identification capabilities comparable to the Boeing RC-135 rivet joint, serving as a sort of mini AWACS. The F-22 provided its pilots with more situational awareness than any other fighter aircraft. It was so good that in 2002, 3 years before the fighter was adopted by the U.S. Air Force, test pilot Mike Dozer Shower and 3 of his colleagues at the controls of the Raptor destroyed 12 F-15Cs in less than 2 minutes during one of the air combat exercises. And this was despite the fact that the F-15 has never lost a single air battle with an enemy aircraft, establishing itself as the record holder of air battles with 104 victories and 0 defeats. But even the Eagle turned out to be just a small bird in the fangs of the Raptor, and now it's time for the big talk. The F-22 has 3 internal weapons bays, the larger main one in the lower part of the body and 2 smaller ones on the sides of the fuselage behind the engine air intakes. For countermeasures such as flares, the engineers designed small compartments behind each of the side compartments. The main compartment accommodates 6 LAU-142A launchers for beyond visual range (BVR) missiles, and each side compartment has a LAU-141A launcher for short-range missiles. The air-to-air setup here is the AIM-120 AMRAAM and AIM-9 Sidewinder, with AIM-260 JATM integration looming on the horizon. It's interesting that the engineers figured out how to make sure that even at the moment of missile launch, the compartment doors are open for less than a second to ensure stealth. During this short period of time, the missiles will be pushed out of the compartment by pneumatic or hydraulic levers. This is also an excellent option for deploying missiles during high-speed flight. Despite the fact that the main compartment was dedicated to air-to-air missiles, the 4 LAU-142A launchers can be replaced by 2 bomb racks, 1,000-pound bomb or 4 250-pound bombs. In total, this gives the aircraft an arsenal of 2,000 pounds of air-to-surface munitions. In 2024, Lockheed Martin's new 1,300-pound Mako hypersonic missile was also added to the list of weapons hidden in the guts of the F-22. Among the main problems that the Raptor could face in the 21st century is the lack of infrared search and tracking, as well as the ability to target a target using a helmet-mounted system. Interestingly, the IRST function was even initially considered as a standard feature for the F-22. However, it was very soon abolished in order to save money. Since the introduction of the first Raptors in 2005, IRST capabilities have not only become more commonplace, but also vital. After all, stealth itself has been quite the priority lately. To avoid wasting a ton of American taxpayer money, the U.S. Air Force decided to get more creative by adding hidden underwing containers mounted outside the hidden fuel tanks instead of the IRST sensor. Like the latter, these sensor containers will reduce the stealth of the aircraft, but at the same time, the negative impact is greatly mitigated by the design that deflects radars and the coating that absorbs them. As for helmets, today the Raptor is the only frontline fighter in the U.S. Air Force fleet that does not have helmet-mounted capability. This forces pilots to point the nose of their aircraft at opponents in order to lock onto a target and fire at it. Yes, thanks to the AN/APG-77 radar and its stealth, the F-22 can attack enemies at a distance of more than 60 miles when they're not even aware of its presence in the airspace, but this is still a significant disadvantage for a modern aircraft. Overall, the proposed AI-integrated avionics upgrade package for the U.S. Raptor fleet includes many solutions that will allow for the foreseeable future to enlist the support of an entire fleet from the collaborative combat aircraft, which are being developed right now for the F-35 Lightning II. At least until the Air Force is ready to present us with an updated 6th-generation fighter program, Next Generation Air Dominance. This means we'll definitely see the reptiles in the sky more than once. Do you think it's worth upgrading the existing Raptors, or is it easier to completely replace them with F-35s and NGAD fighters? Share your thoughts in the comments below, and if you enjoyed the video, please leave a like, subscribe to the channel, and hit that notification bell for more content like today's. Thanks for watching, and we'll see you in the next one.